So in this question, we are going to see a graph theory based question of 1 mark, and it is from the paper GATE 2012, and the topic is based on is planar graphs. So let's see what the question is. Now the question reads, let G be a simple undirected planar graph on 10 vertices and 15 edges. So let's quickly make a note of the data that is given to us. First of all, the given graph is a planar graph, right? Then the number of vertices are 10 and the number of edges are 15. Now let's go further. If G is a connected graph, so it's a connected graph, there are no different connected components, it's a one single connected graph, then the number of bounded faces in any embedding of G on the plane is equal to. So we have to find the number of bounded faces. So what's the concept of bounded faces? Let me just underline it. Okay, so let's consider a random planar graph. So I'll just draw a random planar graph here with 4 vertices. Let me connect it like this. Let me draw it like this. Okay, so yeah, as we can see that this graph, let me write the number of vertices. The number of vertices are 4. The number of edges are equal to 5. So as you can see, this graph, it divides this plane in 3 faces. Okay, this is my phase 1, this is my phase 2, and this is my phase 3. So as you can see, phase 3 is unbounded. Okay, it doesn't have any bounding, whereas phase 1 and phase 2, they are bounded by these edges. They are closed by this. By bounded we mean it's closed. So this is a closed phase, phase 1, and this is also closed phase, phase 2. Okay, so now so this is for this graph. It's a simple graph with 4 vertices and 5 edges. Now they're saying if we are given this graph with 10 vertices and 15 edges, then what is the number of bounded faces? So we have a Euler's theorem for planar graph. Let me write it here down. Euler's theorem. So it gives us an interesting relationship between the number of vertices, edges, and the number of faces. It says that faces is equal to E minus V plus 2. Okay, this is a simple mathematical relation between them. Okay, so we are going to use this Euler's theorem. It's applicable only to planar graphs. So let me just make a note here. It's only applicable to planar graphs. Okay, so if we input our values here, it becomes 15 minus 10 plus 2, and that is equal to 5 plus 2, 7. So this input graph that they have given in the question, it will divide your plane. Okay, that's what they're asking. In the embedding of the graph on a plane, it will divide your plane into 7 faces, just the way it was done here. It will divide your plane into 7 faces. Now, out of those 7 faces, 1 will always be unbounded. This one, it will not have any edges, and the remaining n-1 faces will have a bound. They will be closed. So we have got 7 as our number of faces. We'll just subtract 1 from there, so it will be 6. So answer becomes 6. Oops. So answer is equal to D, option 6.